video, I have showed to you about how to solve the differential equation of IVP and BVP by using Laplace. All right. So we are going to apply the Laplace transform and inverse Laplace transform in order to solve the differential equation. So these are the steps. Okay, we have to transform. We have to rewrite the dE in terms of Laplace transform. And then we have to insert the given initial condition, rearrange the equation, and determine the inverse. So this is the process. You have the differential equation, okay? And then this is y prime. So you have the differential equation, and you apply Laplace transform to get ys. So you transform, you apply Laplace transform means you transform every single things in the differential equation given. So transforming dy dt, transforming y prime, you get sys minus y naught. This one, transforming y, transforming 4. So this is the process of transformation. Okay, so that is your first step. And then insert the given condition y naught. Rearrange the equation. So you have to have ys. The solution should be in terms of ys. And determine the inverse. So you have your ys. To get yt, you should inverse the ys. Okay, so this is yt inverse of ys. So this is the process of finding the solution of yt. So the original problem is in terms of y and t. So your final solution should be yt. So this has been discussed in the video that I have attached. I hope you can see it after this, or you have see it. That is good for you. Okay, that one is for dy dt for first order. Same process with second order, but this that y double prime, we just use the transformation of y double prime. Then the process is quite similar. Okay, after we solve the dE by using Laplace, then we are going to solve the system of differential equation, where solving this system means it needs to be solving the differential equation in terms of simultaneous equation. Okay, so in order to ease the process, here I have shown to you the solution step about solving the x dt and dy dt here by using Cramer's. All of this explanation has been discussed in the video. Okay, so before we proceed, any question? Okay, all right, good. So I hope you can see it again or revise it again through the video. So as for today, I'm going to proceed with our next chapter, which is Fourier. And I'm sorry for the late attachment. I have attached the notes in your e-learning. Okay, so let's discuss it today. What is Fourier series? Okay. All right. So in Fourier series, okay, in Fourier series, what we're going to learn is on about the periodic function, okay, and how to apply the Fourier series in periodic function, then you have to know the even and odd function. Okay, and then we can find the Fourier series for periodic function and Fourier series for half range expansion. So what is Fourier series actually? So before this we have Laplace transform. So after this, not for this syllabus, not for DE, maybe in your engineering application there are Fourier transform. So before you can use that, we have to know this Fourier series. Okay, so this Fourier series knowledge will be also used in solving partial differential equation later in chapter 5. Right? So now this is the basic of Fourier series, the fundamental theory of Fourier series that you need to know, where it starts with how about the periodic function of even and odd, and then how can you find the Fourier series for periodic function and also for half range expansion. Okay, so there are three objectives for the topic here. You can sketch the graph of periodic function, and then you can determine whether the periodic function is odd or even. And of course, we want to find the Fourier series expansion. So this knowledge is important for you in order to apply to solve the partial differential equation in chapter 5 and also in Fourier transform later on. Okay, not in this course, but maybe later in your engineering course. All right. So as I have mentioned earlier, there are lots of transform. We have Laplace transform, we have Fourier transform, we have Z transform, and so on. Okay, so these are one of the transformation process. Then we have also done with the Laplace, and now let's focus on this Fourier. So let's start with what is periodic function. Okay, so basically based on the notes given, okay, what is periodic function? So the periodic function here is defined by, oops, okay, so a function of t is periodic with period of t if ft plus t equals to ft. So the periodic function is defined by ft plus t equals to t, where t is what? T is not equals to 0. Okay, and t is period time. All right, so how can we identify the periodic function? You have to make sure that your function is equivalent to ft plus t. Okay, now let's show this fx is a periodic function or not and find its period. Okay. So now, if your fx is cos 2 pi x, okay, then you have to know that fx plus t should be cos 2 pi x plus t. And you have to show that these two functions are equal so that it can be a periodic function. Okay, clear not? You have your function, okay? You have to make sure that the function, when it plus with a period, where it can be cos 2 pi x plus t, is equal to the original function of cos 2 pi x. So we need to do some proving process here. Okay. So note that the definition of a periodic function is fx plus t equals to fx. So here we use t, then here is t. Now this is x, this is x. Okay, your function is in terms of x. So fx plus t is given by what? Fx plus t here is cos 2 pi x plus t. All right, cos 2 pi x plus t. Now we want to simplify so that it can be cos 2 pi x. Okay, so by identity, it can be expand to cos 2 pi x cos 2 pi t minus sine 2 pi x sine 2 pi t. So this is what? This is by identity. Okay, we expand this by using the identity of trigonometric. Okay, so we want to make sure that this cos here equals to fx, where fx is cos 2 pi x. So from here, from the expand function of cos 2 pi x plus t, in order to make sure that it is equals to cos 2 pi x, so this one should be what? This one should be what? This one should equals to 1, right? And this one should equals to 0. If this is 0, if this is 1, then it can be cos 2 pi x. So now we have to determine what is the value of t, so that this is equals to 1, this is equals to 0. Is that clear? Understand or not? Anyone has question? Okay, good. So now, we can write this in order to find t. So here should be what? Cos 2 pi t equals to 1. Sine 2 pi t equals to 0. Okay. Fx plus t equals to fx if cos 2 pi t equals to 1, sine 2 pi t equals to 0. All right, so now we can find what is the value of t. Okay. So when cos 2 pi t equals to 0, cos 2 pi t equals to 1. What is t? Cos 2 pi is always equals to what? Cos 2 pi is always equals to 1. So this is 1. This is t. This is 1. So t equals to 1. Okay. Then sine 2 pi equals to what? Sine 2 pi is equals to 0. So this is 0. Then 0 equals to 0. So no solution of this. So let's just proceed with this. Okay. Then, all right. So then, what can we conclude here is, by looking at your notes, okay, if you have various values of t, then you can choose the smallest value for t as your fundamental period. Therefore, fx equals to cos 2 pi x is a periodic function with a period of 1. So what can we conclude here is, therefore, fx equals to, fx plus t equals to fx when t equals to 1. All right, clear or not? So fx plus t is what? Cos 2 pi x plus t equals to cos 2 pi x. So your fx plus t equals to cos 2 pi x plus 1. Okay, so this is periodic function. So in order to make sure that this is a periodic function, you have to show whether that ft plus t equals to ft and t cannot be 0. Okay, so this is the definition of periodic function. Okay, anyone has question? Any question? All of you understand? Is it enough, Lizong? Okay, no question? All of you understand this? So what is periodic function again? Fx plus t equals to fx. Ft plus t equals to ft. You have to show and then you have to find the value of t. Okay, let's try the next example. Determine whether fx is sine 5x. Here is a periodic function. So if yes, find the period. Okay, let's try. So now your fx equals to as a sine 5x. So in order to make sure that this is a periodic function, you have to show that your fx plus t equals to fx. Okay, and you can find what is your t. So fx is given by sine 5x, then fx plus t is sine 5x plus t. Okay, where sine 5x plus t by identity, it can be written as what? Sine 5x cos 5t plus cos 5x sine 5t. Okay, this is by identity. Right? Where this is in the form of sine A plus B. Okay, now in order to make sure that this 5x, fx plus t equals to fx, what you need to make sure here is to show that this should be equals to what? This should be equals to what? Cos 5t equals to? All right, good. 1. And this equals to 0. Okay. So you can find the value of t. So cos 5t equals to 1. Then 5t equals to at cos 1. So t equals to what? T equals to, this is 2 pi over 5. Okay. All right. Understand or not?
Yes, okay.
You want- Because cos 2 pi equals to 1, right? Cos what equals to 1? Cos 2 pi equals to 1. Lagi apa? Cos pi. Cos 2 pi. Cos 0 also equals to 1, right? But here we choose 5t equals to 2 pi. Okay, we cannot choose 5t equals to 0 because t cannot be 0. Remember, period cannot be 0 here. Okay, then we choose cos 2 pi. All right. Okay, clear, everyone?
Yes, sir.
So what? Yes?
Yes.
Okay, so what can we conclude is fx plus t equals to sine 5x plus 5t. Sorry. No. Fx equals to sine 5x is a periodic function where fx plus t equals to sine 5x plus 5t and t equals to 2 pi over 5. Okay, so now this is how we can prove whether that function is a periodic function or not. Okay, so now let's proceed with what is even and odd function. So that is a periodic function. Now we want to identify what is even and odd function. Okay, read it first. All right, so now this even and odd function is important for you to identify the types of graph the types of expansion that you have to do after this. Okay, so what is even and odd? Okay, so fx is even when f negative x is fx. Okay, fx is odd when f negative x equals to negative fx. Okay, so now this is the definition in terms of function. And graphically, for even function, so the graph is symmetric about what? The graph is symmetric about y axis. Okay. And for odd function, the graph is symmetric about the x-axis. So graphically, we can plot this graph. Okay. This is the definition. of even and odd. But in terms of geometric, for even function, the graph is symmetric about the y-axis. So, example, here we have a function of quadratic. Okay, then this graph is symmetric about the y-axis. As you can see, it is a reflection on y-axis here, right? Okay, and then for odd function, the graph is symmetric about the origin, where the reflection line here lies here. Okay, the graph is symmetric about the origin. All right. So now this is the difference between even and odd function graphically. So if none of 1 and 2 here, 1 and 2 here are satisfied, then fx is called neither even nor odd. All right. So let's take a look at the example. Determine whether the following functions are even, odd, or neither. Okay. So let's use the definition first. Fx equals to x squared. Is it even, odd, or neither? So how can you use this definition? You just apply what if you substitute that x with f negative x. Okay, if you have you obtain fx, then it is even. If you obtain negative fx, then it is odd. If neither one of these two, then it is neither even nor odd. So let's try the first one here. This is easy. Okay, so when fx equals to x squared, all right, then f negative x should be negative x squared, which is equals to x squared, equivalent to fx. So f negative x here equals to fx, then this one is even. Okay. Right, second one, hx equals to sine x. So h negative x equals to sine negative x. Okay, where sine negative x is equals to 0 minus x. By identity, this can be written as sine 0 cos x minus cos 0 sine x. Sine 0 is 0, cos 0 is 1, which equals to negative sine x. So h negative x is negative sine x, which equals to negative hx, then it is odd. Okay. Understand or not? The difference between even and odd here. Anyone else question? Okay, try the third one. Try the third one. Gx is x to the power of 1 over 3 minus sine x. Use sine x in the second question there. You have sine x there. Try to prove the third one. Is it even or odd or neither? Start with using h negative x, f negative x, g negative x. So try to substitute negative x in the original function and then let's see what happens. So this is how we obtain the characteristic of the function of even or odd. Okay, now let's take a look at the properties. Okay, try to read first. Okay, so these are the properties of even and odd. So now you know what is a periodic function, okay, where the function are equal when you have in the value of t, the value of period. Okay, and then you identify what is even and odd function. Right, so now you know that this is the definition of even and odd. So by using graph, it is symmetric about y-axis and origin, both for even and odd. Okay, and you have done with identifying what is the even function, what is the odd function, how can you prove it. So now let's use these properties. Okay, these properties is important for you to apply to or to implement in the Fourier series after this. Okay, so when you have even and when you have a two function, okay, and you plus, you subtract, you multiply or you divide, what is the product of those two functions? So let's say here, when even plus or minus with even, you got even, right? When even, when odd plus minus with odd, you get odd. When even plus minus with odd, you got neither. Okay, so same function will give you, same even function will give you even. Same odd function will give you odd. Different even and odd function will give you neither for addition and subtraction. Okay, then for multiply and division here, we have even, multiply or divide with even, you get even. Odd, multiply or divide with odd, you get even. Odd, multiply or divide with even, you get odd. So for multiplication and division here, same function of even only will give you even. Okay, and then for odd, and odd will give you even, odd and even will give you odd. So there is a difference here. So in terms of integral properties, this is the properties of addition, subtraction, multiplication, and division. And in terms of integral properties, when you have even function, you know that even function is symmetric about y-axis. Okay, when you integrate from -2 to 2 will give you 2 times integrate from 0 to L f x dx. So you just need to multiply 2 with integrate from 0 to L here. Same, because this is symmetric about y-axis. Alright, so this integration of minus L to L of fx with respect to x is equivalent to 2 integrate from 0 to L of x dx. So here we have x squared. You want to integrate from -2 to 2. So you just integrate from 0 to 2 only. Then just multiply with 2 to get the whole shaded region there. Okay, that one is for even. Okay, next, for odd. If you integrate from -L to L, because this is symmetric about the origin. So this is the reflection line here. Okay, when you integrate from minus L to L, it is equals to 0 because the lower one here will give you negative value and the upper one here will give you positive value. So because it is a metric about the origin and this is odd function, when you integrate from minus L to L, you always get 0. Okay, so this is the properties. And then it is important to understand these integral properties of even and odd before you can proceed with the Fourier series later on. Okay, any question? Okay, so next, once you understand what is even, what is odd, what is neither function, then you can form the Fourier expansion. Okay, Fourier series of periodic function consisting sine and cos. Okay. All right. So now this is Fourier series. What is Fourier series actually? Why you have to understand which one is even, which one is odd before you can proceed with Fourier series. Okay, so this Fourier series by definition is defined as expansion. Okay, we want to expand the function of in a series of sines and cosines. Okay, this Fourier series is defined as expansion of a function in a series of sines and cosines. So this is the definition. Okay, as you can see here. All right, so Fourier series is given by A naught over 2 plus the summation of an cos n pi x over L plus bn sine n pi x over L. All right, so here we have n pi x over L and pi x over L. So what is A naught, an and bn here? Okay, so now try to understand this. This is definition. This is the definition of Fourier series. Okay, and what is a Fourier series? Expansion of a function. Okay, we want to expand the periodic function in terms of sines and cosine. Remember, our periodic function is only fx plus t. So we want to expand this in terms of sine and cosine. So how can it is expand? By using this definition. A naught over 2 plus summation of an cos n pi x over L plus bn sine n pi x over L. Where a naught, an and bn can be expressed. A naught, an and bn here is a constant of Fourier series where we can evaluate this a naught, an and bn by using this formula. Okay, and L is equals to T over 2, and remember T is the period of periodic function. Okay, so this is the definition of Fourier series. Okay, so the first one here is for full Fourier series. Okay, now let's take a look. Fx consists of a0, an, and bn, and these are the ways of how can you find an and bn. All right, now this a0, an, and bn is actually determined by this fx. When fx is even, okay, when fx is even, then bn equals to 0. So when fx is even, this bn, this one, equals to 0. So no need to find bn, just find a0 and bn. a0 and bn. Sorry, a0 and an. So as you can see in the Fourier series expansion, there is no bn here, only a0 and an. This one, there is no bn there. Okay? When fx is odd, then a0 and an equals to 0. So your Fourier series only consists of bn. a0, an equals to 0. Then how can you find bn? Same. How can you find a0, an, and bn is same. Either it is even or odd or neither. But you have to make sure, you have to understand that for even, bn is 0. For odd, a0, an is 0. Okay, and how can you find it? By using the same one. And if it is neither, this is even, this is odd. Okay, this is even, this is odd. And if the function is neither even nor odd, then only then you have to find full version of a0 and an and bn. So the summary here, for fx is neither, then we use formula 1, full. For fx is even, then we use formula 2, only find a0 and an. This is even. Right? For fx is odd, then we find formula 3, where you have to only find bn because a0 and an is 0. Okay, clear not? By using the definition and the formula here. Is it clear for you? Okay. Anyone has question right now from 1 to 10? Where are you? Okay. So now let's take a look at the example. We want to find the Fourier series for fx equals to negative x and fx plus 2 equals to fx here. Okay, first, this is a function of negative x. And you know that fx equals to negative x here is what? Even or odd? Ready? Fx equals to negative x is even or odd? Okay, it is odd function. How can you know that it is odd function? You just can prove by definition, or you just can plot. Okay, now recall the periodic function definition. This is a periodic function. Of course, this is a periodic function because it is given fx plus 2 equals to fx, where you know that fx plus t equals to fx. When fx plus t equals to fx, so this is a periodic function where, as you can see here, t equals to 2. Okay, so for this case, t is given equals to 2. But what if t is not given? Okay, when t is not given, you can find t through the range given. So where the range given here is in terms of negative L to L. And you know that t equals to what? L equals to t over 2. So L equals to t over 2. When L equals to t over 2, then t equals to 2L. So L here is 1, t equals to 2. Same, right? So this is how you obtain the value of t. Why it is important for you to find t? To find L? Because we have to have the value of L there, okay? In the Fourier series expansion. All right. Now, you have identified your t and L. So this is your t, okay? And then this is your L. L equals to 1. Okay, so that is your first step. Identify, it is a periodic function. And then what is your t and what is your L? Okay, next, what is your next step? Now, identify it is even or odd. Okay, so by graph, this fx equals to negative x can be illustrated as like this, right? Okay, where the symmetric is about the origin. So this is the symmetric line, the reflection line there. Okay, and then if by graph you want to plot the periodic function, means that at t equals to 2, it is repeated. Repeated, repeated, repeated. So this is the definition of the periodic function. It is a repeated function at t equals to 2. Okay? But for this case, we just consider at from negative 1 to 1. This is from negative 1 to 1. We just consider this function. But for the case of periodic function, it is a repeated function like this. Okay, clear or not? Understand or not? Now, you can see the symmetric is about the origin. Then we can conclude that this is odd function. Okay? So we have done with finding L and T and identify odd function. Now you know that this is odd. Okay? Then you can decide which case of this Fourier series the function is odd. So formula 1, 2, or 3 by using this one. So we use the third formula here. Okay? Where in the third formula here, you know that A0 and AN equals to 0. So you just need to find your AN. So the third step, we calculate the Fourier series. Okay, A0, AN is 0. So need to find BN only. right? And of course, our fx here should be written as summation of bn sine n pi x over l. And we can find bn by integrate. Okay, we find bn by integrate 2 over l. L is what? L is 1, right? L is 1. Refer to this example. Okay, integrate from 0 to L. L is 1. Fx is negative x, right? Fx is negative x. Sine n pi x over L. N pi x over 1. Integrate with respect to 1. Okay, putting negative outside. Okay, then we can integrate this x sine n pi x, right, by using tabular or by using integration by part. Is that clear or not? Up to this point. N is n. Okay, n is n. All right, now, so let's say you will use integration by part. So your u is x and dv is sine n pi x. Okay, so here differentiate, you get 1 and v integrate, and then you get negative cos n pi x over n pi. So substitute, we have negative 2 uv minus v du u v uv. So minus x cos n pi x over n pi. Okay. Minus integrate v du. Okay. So here you can have this one plus n pi squared. So plus sine n pi x over n pi squared. Right. To simplify everything here, this is 1, 1 negative 1. Sine n pi over n pi squared minus sine 0. All right, then this is 0, right? This is also 0. Okay, so remarks that sine n pi is always equals to 0 because sine pi is 0, sine 2 pi is 0, sine 3 pi is 0, right? This one. So sine n pi is 0. Same with cos. Cos n pi. Cos pi equals to negative 1. cos 2 pi equals to 1. Okay. Cos 0 equals to 1. Then cos n pi we can write as negative 1 to the power of n. When n is 0, it is negative 1 to the power of 0. When n is 1, it is negative 1 to the power of 1. When n is 2, negative 1 to the power of 2. So it is alternately sign changing there. Then we can simplify this. So negative is negative. Cos n pi is negative 1 to the power of n over n pi. This one is 0. And sine n pi is 0. So we can simplify this to negative 2. Sorry, negative is positive. Positive 2 minus 1 to the power of n over n pi. So this is your Bn. Okay, remember it is a Fourier series. That's why we have n. Okay, it is a series of n. And remember that fx is the summation of n from 1 to infinity Bn sine n pi x over L. Now the Fourier series can be written as summation of Bn sine n pi x. So summation of Bn. So this is 2, this is pi, then we just can put outside as a constant. So negative 1 to the power of n over n. Okay, sine n pi x over L. Sine n pi x over L. L is 1. Okay, so this is a Fourier series. So actually what we have been doing just now, we expand negative x here, the original function of fx equals to negative x, we expand to the Fourier series in terms of sine and cosine by identifying the value of L, the value of t, type of the function. Why it is important to understand the type of the function? Then you can decide which case or which formula that you have to follow to form the Fourier series. So case number 3, where a0 an equals to 0, then just proceed with find Bn. So substitute everything and find the value of Bn, and at the end just substitute again to the Fourier series expansion. Now this is the Fourier series for fx equals to negative x. Okay, clear now? Anyone's question? Okay, try to understand first.
Excuse me, doctor.
Yes.
What is the meaning of A?
A,
Yes, sine n pi A. Is there a
where is A?
at the Fourier
This is
series? Sine n pi, is that an A at the answer there?
no, this is x. one?
Sorry?
You mean this one?
Yes.
This is x, n pi x.
X, oh, that's why. I'm wondering what does that mean.
Okay, this one, we have to follow the Fourier series, n pi x over L there. All right? Not A. Sorry. This is x. So actually, this is n pi x over L. But you know that L equals to 1, right? So just substitute 1. That's why we have n pi x only. Okay? All right, everyone? Clear or not? Okay, so what we have been doing just now, we understand that function is a periodic function. Okay, why? Because only periodic function can be expanded to a Fourier series. We know that the function is a periodic, then we can find the Fourier series. Okay, that is the first one. And then you identify the types of function. Is it even or odd? So that even or odd will determine what is the Fourier series that you need to find. So if it is even, then you just need to find a naught and an. And if it is odd, then you just need to find bn. But if it is neither, you have to find it all, a naught, an, and bn. All right. So this is what we have been doing just now. Understanding periodic function, even and odd, and then even and odd can be easily evaluated by plotting the graph. Okay, look at the symmetric line there. All right, then you can form the Fourier series expansion. All right, so this is the first example. Okay, I'm going to explain briefly about the next example, but no need to do it just right now. Okay, before that, this is, you know that fx is odd, right? Here, you know that fx is odd. By looking at the properties, when it is odd function, fx is odd, no, fx is even or odd. Fx is even, sorry. When fx is even, this is even, okay, multiply here with even, multiply with sine is what? Sine is odd. Even multiply with odd multiply with even, then you got odd. So actually this Vn is equals to 1 over L negative FL over negative, sorry, 1 over L negative L integrate from negative L to L fx sine n pi x. Okay. Okay. Sorry. What? This one, this fx is equals to negative x, right? That is odd. And you know that sine is odd. Mana tadi? Sine is odd here. And this is odd. So odd times with odd, you get what? You get even. So integrating Vn is integrate from 1 over L minus L over to L of fx. Okay, so since you know that this is even, then we can use the integral properties of even by 2 over L integrate from 0 to L fx sine n pi x. If you want to use this, okay, if you want to use this, it is okay too. But maybe you will face such a long calculation. So that's why it is important for you to simplify by using the properties where it is given here. I just explain it again. All right. So that is the importance of understanding the properties of even and odd function there. Okay. So now what we are doing is performing the integrate properties there in order to obtain this Fourier series expansion. Okay, now let's try another example. Let's try to understand another example. But no need to do it today. We will discuss it again in our next class because this is quite such a long calculation. But at least you can understand and try it by your own first. Example 5. Okay, so for this example, it is a piecewise function, okay, where fx is negative x from minus pi to 0, and fx is x from 0 to pi. Okay, and generally, this is in terms of minus L to 0, and here is 0 to L. And you know that your L equals to what? Your L equals to pi, and L equals to T over 2. So T equals to 2 pi. And it is given already. T equals to 2 pi. And you know that when fx plus t equals to fx and t equals to 2 pi, fx plus 2 pi equals to fx. So this is a periodic function. And since this is a periodic function, we can find the Fourier series. Okay, so now understanding the type of function here. So try to plot this. What is the types of this fx? Is it even or odd? So because we have a piecewise function here, the easiest way is only to plot. Okay, so now how can we plot this? So from minus pi to 0, it is negative x. And then from 0 to pi, it is x. Okay, then it is repeated about 2 pi. Okay, so this one is repeated about 2 pi. So this is the difference, 3 pi minus pi. So it is repeated again. Okay, so now as you can see from the shape of the graph here, is it even or odd? Where does this graph symmetric about? Y axis. Then it is even. Yes, good. So fx is even. Then when fx is even, which formula? Which case? 1, 2, or 3? Even. Formula number 2 where Bn is 0. Right. Okay. So you know that this is even. Then we can refer to second formula where we have to find EvenOdd and an. So how can you find it? By substituting L. What is L? What is fx? And then integrating from 0 to L. Same process, but just a different integration. Okay, is that clear? Understand or not? The process first. Later on, in our next class, we can discuss it again. We have done with identify the value of L, identify T, and then types of function, and then decide which cases. Then you can integrate. Once you find your EvenOdd and an, just substitute and you can get your Fourier series. Is that clear, guys? All right, so I think we can stop here just now. Okay, good question. When integrating fx, use negative x or x. So you have to refer to the range. You have to refer to the range. Okay, let's. Okay, before I forgot, let me show you. Okay, for EvenOdd, now let's take a look at EvenOdd. EvenOdd is 2 over L. L is what? L is pi. Integrate from 0 to pi of fx. So now you have to check from 0 to pi, which fx? So from 0 to pi, so this one. So your fx is x. Okay. Refer to the range. So your function refer to the range. All right? Because we have two functions there in terms of a piecewise function. Okay, so I'm going to leave you with this example. You can try it. All right. Then later in our next class, you can discuss the next example. Or if you want to try it by your own, it also can. All right, so that's it. Anyone has question for today's lesson? Is it hard? But at least you understand, right? From 1 to 10, where is your understanding? All right, good. Try to do it again from the first topic here by your own. compare with our discussion today. Okay, once you can understand and do it by your own, and then you can try to implement the Fourier series expansion there. Okay, so if you have no more question, I think we can stop. I'm going to share the recording after this so we can refer. Don't forget to scan the attendance here. Okay, let me share the attendance first. No more question? All right. Let's end our class with Surah Al-Fatiha. Let's end our class with Surah Al-As in the Spectora. And don't forget to scan this. And thank you, everyone. Assalamualaikum.
Thank you, Doctor.
Okay.